Well, hello and welcome to this exercise on vector geometry, an AS or additional mathematics type question here. And it says the diagram shows a cube with sides 4 centimeters and a plane CDOF. And on this plane here, we've got a point P there. Right, got a point P on this plane here. Okay, right. It then says find vectors OD and DC. Now, to find vector OD, we need to find the coordinates of D, and that's 404, and that's because to get to D from the origin, we move 4 centimeters parallel to x-axis, and then 4 parallel to the z-axis. We do not move parallel to the y-axis, so it's 404. So that these now are the coordinates of point D. Now, having found the coordinates of point D, we are now in a position to find vector OD. Now, to find vector OD, we subtract the coordinates of the origin, which is 0, 0, 0, from the coordinates of the point D. So 4 minus 0 is 4, 0 minus 0 is 0, 4 minus 0 is 4. So this here now are the components of vector OD. Right. Similarly, we need to find the coordinates of vector C. Sorry, the coordinates of the point C. And the coordinates of point C are 4, 4, 4 because we think we can move to get from the origin to C. We move 4 units parallel to the x-axis, 4 units parallel to the y-axis, and then 4 units parallel to the z-axis, and that gets us to the point C there. So the coordinates of C are 4, 4, 4. Now we are now in a position to find the vector DC. And to find the vector DC, we subtract the coordinates of vector D from the coordinates of vector C. And that will give us a DC component of, the components of vector DC will be 0, 4, 0. Okay, now that's part A. Now for part B, it says find the position vector of P. Now don't forget that for P here, we do not know the coordinates of the point P. Okay, we do not know the coordinates of the point P. So what I've done here is to, if I've given the vector OD a value of A and the vector DC a value of B. That will save me saying 404 all the time. So we want to get from O to P, but we do not know the coordinates of P. So we need to go to P via what we already know. We know the value of vector OD and we know the value of vector DC. So we're going to go via this truth here, this one here as shown here, and then parallel to vector DC. Now, these two coordinates here, this one here and that one there, are the same. Now, they're just part of DC. They're parallel to DC and in the same direction of DC. So those two vectors are the same, even though they're only a fraction of OD and DC. So OP, to go from O to P, we have to go via a fraction of OD and then a fraction of DC. So in effect, what you then have is that the vector OP is now T times A plus S times B. Now, T will be this fraction shown here, and then S will be this fraction shown here. So in effect, vector OP is a multiple of OD plus a multiple of DC. Now it just happens that in this case T and S will be fractions, but it doesn't matter, because if you extend the plane CDOF, P could be anywhere on that plane, so T can be any number. So I hope all that made some sense, and just to summarize, that the position vector of OP will be DA plus SB. So we're adding two multiples there. Now I hope all that made some sense, and please subscribe. Thank you for watching, and bye bye now. Bye bye.